Thanks, Susanna, and thanks for joining us, everybody. So, um, yeah, so just a reminder too that these slides will be made available after the session. I'll send you a link so you can just sort of not have to take so many notes. So today's webinar is about the science behind showing working. So, and the things we're going to explore is why is it important that students show working when solving maths problems? Some of that is obvious. What does the research say about the benefits of reading and writing solutions? How does unpacking work solutions help students learn with confidence and mastery? And how are these strategies integrated into the new editions of Maths in Focus? So Nadia is going to lead us through the research and the strategies behind showing working, because we've decided that with the new editions of Maths in Focus, we are going to revamp our work solutions and provide a lot more structure. So over to you, Nadia.
And thank you, Robert. Welcome, everybody. Thank you for joining us today. I'm really excited to walk you through this webinar. And as always, I like to start with something a little bit thought-provoking. This is a quote by Seneca, who was an ancient Greek, I think, philosopher. If you don't know what harbour you are going to, no wind is a good wind. And I thought that this was pretty sort of telling in this particular climate. And now that we're talking about work solutions and how we're moving into mathematics, particularly at a secondary level, it really sort of speaks to some of the challenges that students are facing when they're learning maths. So I'm going to just walk you through some of those challenges. So particularly when they're looking at examinations, because the end result for students at HSC are doing really well in those end of year exams. So content challenges, obviously the gaps in knowledge and difficulty connecting topics. So things like exam anxiety, and speed versus accuracy is another one that really needs to students need to practice through with successful exams. Poor exam skills, like unpacking the language of exams, where the grades are all allocated, questions that have unfamiliar context to them, things like that, and preparation issues. And you don't sort of think about over-reliance on practice exams as being a limiter, but sometimes when the students are just in that drill and kill phase of unpacking questions from exam papers, it kind of pigeonholes them into just, if they come across a question that they're unfamiliar with, it can really cause some issues there. So what we have really thought about is this here, and that is, if we want students to model good understanding in maths and in exams, it's important that we model good solutions. So that's the least sort of point that we can start, I guess. So we have done just that. But before I go into that, I want to talk a little bit about what the research says. And I'm just going to go into this very quickly, because when we were putting together these solutions, it was important for us to understand the best way of, I guess, setting out the solutions so that the students could get the most benefit out of them. And what we found was that in many cases, not all cases, but in many cases, things like worked solutions or fully worked solutions, worked examples and things like that actually boost student performance. So they were linked to higher maths achievement. They eased cognitive load, and cognitive load is a big one because it exposed them to a lot more scaffolded kind of issues. It removed that sort of intrinsic load that made it difficult to sort of retain information and to transfer those. It accelerated learning. So it reduced processing time, decreased mathematical errors in subsequent problems, and it really did build those transferable skills. So that those were the main ones. And finally, it did strengthen understanding. So the research did definitively say that worked solution or having students work alongside work solutions or worked examples did improve procedural skills significantly and reduce misconceptions. So we kind of took that on board when we were developing our work solutions, and for this reason, and Robert's going to talk to this slide.
Oh yeah, okay. So when I was reading through all that, I thought, oh, this really ties in well with the what works best, which is the set of 8 different skills or 8 practices of effective teaching that were. And I'm a big fan of what works best, and it came out 10 years ago, but they refreshed it in 2020, and they've refreshed it again this year. So this really ties in with explicit teaching and also effective feedback, because the best way to tell the students to know what to do is to show them what to do, or show them how to set out their work, because often they don't know, they don't know what a model best solution looks like. So explicit teaching says it's teachers demonstrating and modeling to students. It's telling them what they're expected to do, how to do it, what it looks like when they have succeeded. So I only read up more about this a couple of days ago, but we've always tried to implement these strategies in publishing and writing these textbooks. So it's very important that we show students not only how to do the maths, but also how to present their working out. I have a son who's in year 12, and he goes to a boys' school, and I think it's one of those things where boys seem to think I can do the answer without showing any working, and that makes me a smarter person. But hopefully, if we lead students through this and make them realize, no, it's not, there's actually a rationale and a science behind showing your working, then we can help them achieve deeper understanding.
Amazing. Absolutely. Thanks, Robert. And with this in mind, what we've done is, for the new editions of the Maths in Focus, we've revamped the old work solutions in order to provide more structure and detail for a deeper understanding. So we've done this for every single question in all 4 of those books. So we're very excited. It was a mammoth effort, but we're really proud of what we've achieved. And I'm going to show you what we've achieved, hopefully, after this slide. So these are our new books. So Year 11's coming out next year. Is that right, Robert?
Oh no, in about 2 months.
In about 2 months, sorry.
There's a slide that's coming up. There'll be a slide about this. So yeah, we are publishing for all the courses. So Maths Standard 1, Maths Standard 2, Maths Advanced, Maths Extension 1, and Maths Extension 2. So if you count them all up, what's that? That's 9 books there.
Yeah.
And in Year 11, we actually published 2 levels for Maths Standard, even though it's 1 course. But we feel that the current course in Year 11 is too hard for one group of students and too easy for another group. So we decided to differentiate and provide a separate pathways, if you like. The other big thing is that these books are now A4 sized.
Yeah, so good. And available soon for ready to implement next year. So ready for your wonderful Year 11s. All right, so I'm going to just take you step by step through our design principles as we were constructing these. So the first example that I'm going to use has been taken from our equations chapter 2, I think it's algebraic techniques. And we look at these 2 questions. So question 5 and question 3. So these are the solutions that we have designed for these questions, and this is very typical of all of the solutions in all of those books. So you'll notice that there is a 2-column layout, and that is deliberate so that the left-hand column will provide prompts, so those thinking steps and any additional prompts, and the right-hand side will show all of the working. So that way the students can distinguish between, what is working and what is just like those promptings for any sort of self-explanation. They can cover them up if they need to, or they can use those as they work through them. So the other thing that we've done is we have, so this next example is taken from differentiation techniques. It is, we have for every multi-part question, so this is from question 1 in 8.06, we have created this. Like it's almost like a very detailed exemplar of the remaining solutions. So the idea behind that is that the students will be able to look at that as a exemplar to use for the remaining questions, because eventually we will reduce the difficulty, I guess, and the scaffolding of the questions as they go through each part. So we'll still have a full worked solution, even if the remaining worked examples don't have every single part. And that was intentionally done. And we'll discuss that at a later time. So, which is right now, the later time. It's for purposeful scaffolding, which means, for example, and this was still taken from chapter 8, differentiation. So for example, 8.06, we introduce the students to the chain rule. And then when it comes to test yourself, we have the expectation that the students would have already or should have already developed those skills. So we remove some of that sort of detail from the work solutions. So they'll still have the original fully worked solutions back in that exercise, but the ones as they move forward will have some of that detail reduced. And the idea is kind of like to encourage that retrieval practice and strengthen the long-term retention that we try to encourage in the students, not just like so that they can commit it to long-term memory, easier for processing. And this is actually, for me, the piece de resistance. Like, these are so good. The HSC problems that we've created in the books, the sample HSC problems, what we've done is we have created an entire marking scheme for them. So the thought behind that was that when students come to do these sample or practice HSC problems, a lot of the times they have very limited marking guidelines. And so we're trying to get them to understand as they're working through these HSC or sample HSC problems where the marks are actually allocated. So here, each of the HSC problems that are in the book have got a mark allocated to it. And these are broken down as they're graded through the logical progressions of the solutions. So I'm going to hand over to Robert for talking through the next few slides.
So when I was talking before about showing students the rationale behind showing working, well, there you have it. Like, if you don't, hopefully by showing them the marking guidelines, they will be more likely to show working, because they know that each line of working is potentially earning a mark. So I've taken some examples from last year's HSC exams, and this is something that I know a lot of teachers do with their students in class as well, where they go through the marking guidelines and they go through the work solutions with them, just with the class, just to show them, 1, how it's done, and 2, where the marks come from. So this is one of those common questions in the HSC, which we won't be getting anymore in the future with the new syllabus, but this is a question about exponential growth and decay. So it's a graph, and it's from last year's exam, Math Standard 2, question 22, but it was also the Math Advanced HSC exam, question 13. It was worth 3 marks, and they basically had to fill in a table, and there were 4 things to fill in on the table, and they had to get all that information from the graph. So 4 things there. So B was 280. You read that off the y-intercept. Percentage yearly change, you work out from the equation of the 1.055 and 0.97, you work out from that. And then the predicted population is you substitute, you substitute 50 into the formula for population W, and you get 494. Now, it's interesting that students are being asked to do 4 things, but it's only worth 3 marks. So I would ask the students, where do you think the 3 marks are awarded? And I guess I'd ask you as well. And I guess it does depend on the marking team that year, but this is how they awarded it. So they awarded 1 mark for 1 thing, 2 marks for 2 things, and then they jumped to 3 marks for the other 2 things. So it's not 4 marks, but it's 3 marks. So yeah, that makes so. But in saying that, that was the marking scheme for last year for this question. It doesn't mean it's going to be the same with every question. It doesn't mean it's going to be the same every year, but it just lets students know that if they get 2 questions right, then they're going to 2 parts of that table right. They're going to get 2 marks out of 3. So, you know, that is one of the reasons why showing working is so important.
Yeah,
Okay.
and we've tried to do that. We've tried to, and these are all of the questions that we've got in our book are sample HSC problems, but we've tried to replicate what we think the marking assessors would potentially focus on, and each question will distribute those marks kind of accordingly, and these comments will kind of go hand in hand with where we think those marks will go. So we have put a lot of thought and work into them. We're still working through them. So these are only, you know, sample pages at the moment. So at some point they'll, you know, get hopefully better and better, we're hoping. So this is another example I'll let Robert talk through.
Can you go back to the last slide for
This
a
one?
second? Yep, this one. So I just wanted to mention that what we've got here is very detailed, and it's not like what NESA provides. So this would be an example of a marking scheme, I think it's called. I'm not a marker, so I don't know the correct terminology. So this is a marking scheme which really drills down exactly what you award a mark for. What NESA published, and what was on the previous slide, is a marking guideline, which gives you a rough idea, and it gives you enough information to guess or estimate what the marking scheme would be. But we try to be fair, and we try to award marks as much as possible for students to show correct working. Now,
and it also will support teachers as well, because I know, especially you know, inexperienced teachers or teachers who are new to teaching VCE out of field, you know, they will be able to see, if you've not taught HSC before, you'll be able to sort of get an idea of how we can talk through the past HSC exam or assessors reports.
Yeah, so this is like a standard, or this A standard, and it's not too lenient and it's not too tough either. And the other thing I wanted to mention about the sample HSC problems is that we have one at the end of every chapter. We try to make up a question in the style of the HSC that exemplifies that chapter, tests as many things as possible in that chapter. But that's not to say that's the only HSC style question we have in the chapters. They're in every exercise as well, and we'll show you some in a minute. But we do single out one for, I guess, showcasing at the end of each chapter, so that we can do this analysis and the mark allocation.
Yep. Speaking of mark allocation.
Okay, so this is a question from last year's Math Standard 2 exam. Okay, I mean, this comes up a lot. There's always some sort of measurement and trigonometry question. So we have to basically find the shaded area left over after the regular pentagon is removed, removed from that circle. So I guess, and then you have to work out the area of the shaded region, the circle, correct to significant figures. It's one of those unscaffolded 4-mark questions that the HSC is now very well known for. And we do have a lot of those in our textbook as well, where students have to work out all the steps involved. And I tell students that with 4 marks, usually means there's 4 steps, and you have to show 4 things. You have to show 4 things. So I guess the first thing is to work out the area of the circle. And you know that the circle has a radius of 30 centimeters. So that's possibly 1 mark. And then the second thing is you're going to have to work out the area of the pentagon. But before you can do that, you've got to work out the area of one of the triangles. So let's work out the area of one of the triangles using the area of a triangle formula. And then you multiply that by 5 to get the area of the pentagon. Okay, so that might be another mark. Who knows? We'll get to that. And then you do the subtraction, I guess. The area of the circle minus the area of the pentagon. And then you have to round off your answer to do significant figures. So have a think about now, everyone, where you think you would award the 4 marks. There's actually, as I said, no right or wrong answer, but this is what they decided last year in the marking scheme. So let's have a look at the next slide. Let's have a look where those marks were. So 1 mark for the area of a circle, 1 mark for the area of one triangle. Yep. And okay, we skipped the pentagon and we got 1 mark for working out the area, the shaded area, but it's or an expression for the shaded area. And then that last mark was for rounding. So this must have been the question in the exam where students were marked, got the mark for correct rounding. So rounding to 2 significant figures. And then the table shows that how it all comes together. Okay, so you read from the bottom up to see how you get each of those marks. Yep, you'll notice there's terms like or equivalent merit. And then in the marking scheme, that would be obviously spelt out a bit more to those HSC markers. Okay, next slide.
So this is just another example of a standard 2. So we've got HSC, sample HSC problems for both standard 2 and extension 1 and advanced. So this is just show you the standard 2, very similar sort of format. This one's quite detailed in what we do, just simply because of the type of question it is. And yeah, so marks are allocated in these as well. So did you want to talk to that, Robert, at all?
I guess a lot of just some very good like HSC style comments and remarks, advice to students advice for students in the future. Yeah. Yeah, they used to NESA used to publish very detailed what were they called, examiners reports, and saying what students got right and wrong. But now they've become a bit more generic. So, but I think these ones here that you worked on, Nadia, are very precise and detailed, which is good.
Like I said, everything that we've done has been intentional, because the bottom line is we're trying to prepare the students as much as we can for those exams. And this especially the one question from every exercise, this is the one that's had the most work. Not that the others haven't, but you can see the detail that's gone into the HSC sample problems. And again, like coincides with, you know, a similar sort of thing for, yeah, those marking schemes for advanced. So we have, yeah, worked really hard on those, and yeah, they're not fully, as I said, there's still work to be done, but yeah, we can only go upwards from here. But what we believe would benefit you guys as teachers are that those ready-made model solutions do save you time. Because there's work solutions for everything, and it's not just the HSC ones, because there are fully worked solutions for everything with detailed notes and annotations, they will save you time, especially in those more difficult, complex questions that sometimes we spend a little bit more time on. We've been very deliberate with using the consistent language across chapters and courses. And if we've used a method of solving in exercise, we've used that same method in the worked examples as well. So we've made sure that anytime that they're seeing the solutions, or anytime that they're coming across language, it's repetitive, so that it will be more, they'll be more likely to familiarize themselves with it and strengthen that. Again, those complex solutions, as I mentioned before, I think especially for teachers who are new to I keep saying VCE, I'm sorry, I'm from Victoria. Don't blame me for that. But HSC, especially if you haven't taught HSC before, they'll be, I think, invaluable. I know they were when I first started teaching VCE. Sorry.
And also if you're teaching out of field as well, or teaching a course for the first time.
Yeah, exactly. They do also support differentiated instruction, and we're going to go through some ways that you can incorporate and use these in your classrooms, just as in lots of different ways, and differentiation comes with that. And again, it's that consistency across teaching teams and year levels as well. So whether you're teaching standard 1, standard 2, extension at both year 11 and year 12, we've kept it consistent all the way through. And finally, this is probably one that you'll like. When we do upload them, because these are all going to be available on our Nelson Mindtap platform, and they can be toggled on and off by teachers. So the default is that they come toggled on, so students and teachers will have access to them, but teachers can switch them off if you want to, not give students access to them for whatever reason. Then you can also switch those off as well. So not all students can have access to them at all time if you do not wish. And for students, we believe that, and we've actually spoken to students and shown them some of the samples, and the resounding agreement was that, particularly when they're doing independent study or study at home where they don't have ready access to a teacher, the solutions are invaluable for them. They also reinforce the key concepts through guided practice and also through repetition as they go through each concept. This is an interesting one. This actually came from actually one of the authors, Andrew Su, who is, I'm not sure if he's here with us today. He teaches extension and advanced, I think, at Knox Grammar School. And he was talking about this over-reliance on AI that students have. So when they get stuck on a problem, or when they can't solve a problem, they put the problem into the AI and the AI spits out the solution. But you don't have control over whatever the AI spits out. So this way, we have reduced, I think, or mitigated that at least, because we've got all of the solutions. If they want to do that and compare, they've still got the solutions that are, that the teacher has delivered, that the book has delivered as well. So I think that one's a really important one. Self-assessment and reflection is also another really, really important point to students having the ability to go through and just assess themselves on what they've done wrong and right. And also, second last, improves exam techniques, obviously, through the targeted markers notes, and supports revision and retrieval. So we think that they will benefit students in this way, but let's have a look at what you guys might do to use them in your classrooms. So I've taken this example. This one is, I think it's chapter 8, differentiation, introduction to differentiation. So the students are asked to sketch a gradient function for each curve. Now, keep in mind that this is probably the first time that students have been introduced to differentiation. So we've spent a lot of time working through this particular chapter. And using the solutions in live demonstrations like this to be able to step the students through. So rather than just having one worked solution to be able to walk them through, you've got all of the solutions that kind of look in a like very similar to this. We've used the exact method that's followed in the book, and that's advised in the book. And so you can use these obviously in your live demonstrations. And if you want to talk through a question that, you know, students are stuck on for whatever reason. They also, so as I said before, as the difficulty is increasing with the questions, so when they're first introduced to this, so this is from the very first exercise, but then when they go further down and further through, the questions are not as, the solutions are not as detailed. So you can see that the solution to question 8 here is, we're not showing exactly how they sketch the function because they should have already had that learning. So we don't need to talk through that with this particular question. But the great thing is that they can use the previous examples to support them in how to draw that graph if they're still not sure. So they can go backwards and forwards between the solutions. And because everything is clearly marked in these part A's for the questions, it's easy to know where each part is. So that color coding has been quite deliberate there.
I guess they can just, I mean, for a new question, they could just read the thinking steps and apply it to the new question. Like,
yeah, exactly.
They've got that scaffolding.
Yeah, that's right. Yeah. So error analysis too. So this is a way that you could use these, and we haven't quite figured out how, like, it would be great if we could turn off some of the thinking steps individually and turn off some of the workings. Well, we haven't quite got there yet, but what you can do is, this is an opportunity where you can toggle the solutions off, give the questions to the students for homework or during class time, and then provide the completed solutions to the students. So here are 2 incorrect student solutions, and once they are presented with the actual solution, they'll be able to go through and self-assess. And rather than you having to go through and say, no, this was wrong, what did that, or in many cases, they don't even know where they've gone wrong, they can sort of go through those thinking steps and try to figure out where they've gone wrong. So you can use them in those ways. They obviously support differentiation for those weaker students who do need the scaffolding, but they also can be a bridge to the advanced students. So if you presented this challenge, if you presented this challenge question or example to the students, even though it doesn't have solutions of its own, they can use some of the previous workings to support their thinking in that challenge question. So that's another way that students can do that as well. And obviously, we've got the homework and exam practice. So if they are given a different type of question, they can go in and have a look at a similar type of question with a solution that's been, you know, solved, look at the steps, and Bob's your uncle. So hopefully be able to figure that out. But yeah, so we really have hopefully thought of everything. We'd love some feedback as to how we can make improvements. But yeah, we'd love to hear some thoughts in the comments. But I'm going to go over to Robert now to talk through some more HSC style questions.
Oh, well, this is what I was saying before, that it's not just, we've got HSC style questions throughout all of our chapters, because that was the main feedback that we got from teachers last year, that that while we were good at explaining the theory and doing examples, we weren't preparing students for the exams well enough, because we didn't have those rich problems that required interpretation, communication, problem solving, that sort of thing. So we have made a concerted effort this time around. All our author teams, including Margaret Grove, has been working hard studying the past HSC exams and trying to write those styles of questions, some scaffolded, some unscaffolded, so some 3 or 4 mark questions that provide no clues. So we've got, so this is, we've been focusing on the chapter 8 of the Maths Extension 1, also the Maths Advanced book called Introduction to Differentiation. So this is just an example from finding the equation of a tangent. And I also wanted to say that you'll notice up on the top right corner, I've highlighted that we also provide videos. So not only do you get work solutions in the written form, but you'll also get a teacher explaining it on video, like one of our flipped classroom teachers, so that students can get it 3 ways, I guess. They can get it from you as a teacher, they can get it in print from the textbook, and then they can get a different explanation from the flipped classroom teacher. So this is a video explanation on tangents and normals. It's another HSC style question because it's not really straightforward. Yeah, it's not even, no scaffolding there. Find the distance between points A and B, and there's a whole lot of steps to go there. And you'll notice there's also closed captioning there. So we're trying to make these videos accessible to all different styles and needs of students. So next slide. So some more worked examples. So these ones are from our Maths Standard 2 book. So this is year 11. This is chapter 8, I think, on networks. So networks has been moved from year 12 to year 11. So this is the section on using Kruskall's algorithm to find a minimum spanning tree. So you'll see how in our solutions we try to use plain English, we try to use diagrams and color to explain step by step just exactly what happens. And I think we also provide video for this worked example as well on the next slide. And yep, so we've got more people doing this. So yep, next slide. Okay, so yeah, you might have missed that before when you were looking at our, these are our exercise sets. So we've also introduced a 3-color code for the different levels. We wanted to differentiate between the 3 levels of questions. So we've got green for foundation, blue for mastery, and red for complex. And not only are they color coded, they're also shape coded, so that students who have a colorblind condition can also be able to differentiate them as well. And you'll also notice that they are HSC style questions, and also like even question 19 tries to use a local reference. So we're not an adaptation of a Victorian text or anything like that. All our content in Maths in Focus is homegrown and written by local authors who are also New South Wales teachers. Okay, next slide. Okay, I've been asked by a lot of teachers to supply our scope and sequence and teaching programs. Teaching programs are still in draft mode, so they will be coming soon. But I just wanted to show you what the scope and sequence is for all our books. So as I said before, in year 11, we provide 2 different alternatives Maths Standard books. You only have to buy one of the books. You don't have to buy both, because both books cover exactly the same content. And it's full coverage too. It's not like the old rhombus symbol content. It's full coverage. So this is our Maths Standard Pathway 1 book, which is for students who will go on, will definitely go on to Maths Standard 1 in year 12. So at the front of each of our books, we do have a syllabus reference grid that maps the syllabus to the different chapters. So you'll notice we mix up the chapters as well, so that they're doing a bit of algebra, then they do a bit of financial math, and then they will go back to algebra later on. So this is what it looks like for Maths Standard Pathway 1, and the next slide will show the actual table of contents. So I'll just let you sort of absorb all that. So year 11, 14 chapters, year 12, 12 chapters, and including a revision chapter on analyzing data, because there's always analyzing data in the final exam. So we didn't want students to have too much a gap from that. And then the next slide looks at the Pathway 2 book. So this is the one more students use. So it's the students who are going to go on to Maths Standard 2. So again, at the front of the book, we've got the syllabus reference grid, and the next slide will show you the scope and sequence. So 11 chapters in year 11 and 11 chapters in year 12. So fairly straightforward. And if you've been using our books in the past, there's only about 10% change in content. So those chapter names look fairly familiar. So for example, networks now is spread over 2 years. So chapter 8 in year 11 is networks, and chapter 6 in year 12 is project and flow networks. Okay, let's have a look at the Margaret Grove books. So the Maths Advanced and Maths Extension 1 books. So, yep, they're written by Margaret Grove. And the next slide will show you the syllabus reference grid. It's actually for Extension 1, but the Advanced book follows the same order as the Extension 1 book, but it just has all the Extension 1 chapters taken out. So you can see the syllabus coverage there. This is us. We've always done this because we want to be accountable that we do cover the syllabus. So the next slide will show the table of contents for Maths Extension 1. So there's 12 chapters in year 11, and there's 15 chapters in year 12, 15 shorter chapters, mind you. And then, as I said before, the Advanced book is just the same, but with all the extension content taken out. So we've tried to provide this for students, for classes. We know that a lot of classes have Maths Advanced and Maths Extension 1 students in the same class. So technically, they could all be using the same textbook, the Extension 1 textbook, but just not the advanced students wouldn't be covering the Extension 1 works. Okay, and I think there's one more, and that's Maths Extension 2, and that's written by Jim Green and Janet Hunter. And you can see there's the 7, it's a shorter book, 7 chapters. There's been a bit of change in Extension 2, but the chapter names haven't changed, but what's inside them has. Okay, now let's go to the next slide. Okay, we mentioned Nelson Mindtap before, so this is our digital platform with all the extra resources. So you can see up there's a little blue panel that shows you all the resources for Chapter 8 differentiation from the Maths Advanced and Extension books. And that's fairly typical that in each book, in each chapter of any book, in any of our books, you'll get a whole bunch of videos that go with the chapter. You'll get like 20 worksheets, and you'll get like 2 puzzles. Actually, that should be 3 puzzles. I can just count it. I'll have to fix that. And then on Nelson Mindtap is where all these resources are stored. And it also comes with an ebook, which includes things like a read aloud feature in an Australian accent. We've got the chapter PDFs for teachers who like to snip the chapters and present the examples on their whiteboards. We've got the videos made by our flipped classroom teachers. We've got over 100 worksheets per book. And then for teachers, we've got topic tests for each chapter. We've got teaching programs, our beloved Work Solutions, our new improved Work Solutions, and the test generator. Now, the important thing is that these resources are only available to schools who adopt the series. So if you buy 1 copy, you don't get access to this, because you do need to use Nelson Mindtap. You do need to register all your students. You do need to register a class. So you have to buy a class set, or you have to book list the series. Okay. Okay, next slide is, our Work Solutions authors. So as you can tell, writing Work Solutions is a big task, and it's almost as much work as writing a textbook, because you have to, for every question, every single question, and there's thousands of questions in a textbook, you have to write the solution to it. So we've got a big team of Work Solutions authors there. And then we've also got our video author team as well, a big team there. So, you know, they're all using their own strengths and talents. And then on the next slide, we've also got people working on the worksheets and the topic tests. Okay, so we've got a big team. So every chapter comes with a topic test, and they're well known and well loved as well. Worksheets, additional content, additional learning content. Yep. Okay, next slide. Okay, I'm going to call in Theo Misios from our learning consultant team. You might know him. He might be one of the teachers who serves your school, and he's going to give you some more sales information.
Thank you, Robert. Hello, everyone. Yes, my name's Theo Misios. I'm one of your learning consultants in the New South Wales area. You may be familiar with Dion Lombard and Sophia Burton. They're also part of the New South Wales team. Yeah, just some key information just to get your head around a little bit. If we go to the next slide, if that's all right. Yeah, beautiful. So just pricing and availability. At the moment, we have Maths in Focus that's coming out and it's going to be published in October, November of this year. So ready for implementation for 2026. And as Robin and Nadia have already explained, year 12 will be ready for 2027. You have those key dates there for November, October for each of the books. And as Robert mentioned as well, we have a print version of each of those textbooks, which is $84.95. And then you have the digital option, which is the ebook for $49.95. And again, if a school does purchase a class set or book list, the actual title, they do get access to the Nelson Mindtap digital platform, which provides all those teacher resources that we've just gone through. So if you have any queries about that, please feel free to reach out to us. I know Susanna's going to give those information for our emails and all those details, so you can reach out to us. We can do demonstration with your staff and take you through that digital platform and provide any additional information or resources that you need. And I believe that's everything from me. So yeah, thank you.
Okay, let's have a look at the next slide then. Thanks, Theo. Okay, so we've got a Nelson Secondary YouTube channel where you can look at our past webinars. Earlier this year, or a couple of months ago, author Sarah Hamper and I did a webinar on changes to the HSC syllabuses and what's new and what's been taken out and what's different. So that's available. That's available on a YouTube channel. There's also like a short overview of what Nelson Mindtap is and how that's available for Maths in Focus. And then this webinar that we're recording will also be available on the YouTube channel. We're also going to be at the Mansfield Conference in a big way this year, 18th to 20th of September. We're going to have a big stand there, so come and say hello to us, where we will show you. You can look at copies of Maths in Focus, and I'm sure there'll be some sort of goodies things to give you. But also on Saturday, 11 a.m., I'm going to be in conversation with Margaret Grove, 3 Decades of Maths in Focus, where I will pretend that we're at a writers' festival and interview her about what it's been like writing Maths in Focus since 1993 and how maths curriculum and maths teaching has changed over that time. Yeah, and I mean, and if you're around, if you've been teaching for a long time, you probably would like to come and see a bit of a retrospective on how maths has changed, the maths education and the syllabus has changed over those 30 years. And then finally, I think we're up to the last slide now. So let's have a look at that. And this is the website where you can download this PowerPoint if you're interested. If you want to see more, if you want to read the slides with a bit more detail, Nadia and I have also left our email addresses there if you want to ask us any more questions or give sources to the research that we've been talking about. And also there's our website where you can find out more about Maths in Focus series.